add it to my list here. Okay. Let's just start with that even odd. So if I gave you, I could ask you a couple different ways. I could ask you even or odd from an equation or from a graph, because we found it both ways, algebraically and graphically. Obviously, you don't have the graphing calculator on the final, so if I asked you about a graph, I would give you that picture and then have you answer questions about it. So let's do one each way. If I said f of x is negative 3x squared plus 7, how do you decide from an equation if it's even or odd? You put in a negative x. If you put in a negative x and you get the exact same thing out, it is even. If you get the exact opposite, it is odd. So if I plug in a negative x, negative squared is positive, times my negative 3 would give me a negative 3x squared plus 7. These are the same, so that means even. Okay. What if I asked you to answer it from a graph? So let's say I gave you this. Even is the same thing as symmetric to the y-axis. Meaning, if I flip this thing over the y-axis, it overlaps itself. Does that work here? No. Odd is symmetric to the origin. Meaning, you have to flip this thing over the y and over the x. So, if I just took like this half of it, okay? If I flip that half over the y, then it looks like this. And then if I take that and flip it over the x, it looks like this. So is it symmetric to the origin? No. So what would this one be? Neither. If it were truly like symmetric to the origin, this one would work, because the problem here was this went down a lot further than this piece went up. So if that was a little more symmetric, then it would have worked. Okay. Is that all right with everybody? Can you answer, like, if I asked you where this graph was increasing, decreasing? You guys know how to do that stuff? Go from left to right. If it's falling, it's decreasing, increasing. And do you list the x or the y values when you give me those intervals? The x. The only time you use the y is if I ask about a range. Okay, so are we good with the even odd? Alright, so I've covered that. Let's do some of the limit stuff. So let's do the asymptotes. Let's say our equation is f of x equals x minus 5 over x squared plus 3x plus 2. Okay, if I ask for vertical asymptotes, how do we get those? Okay, to get horizontal, we have to do the limit as we approach positive and negative infinity. And to get vertical, we just have to figure out what makes the bottom 0. So to figure out what makes the bottom 0, where would I probably begin? Yeah, breaking it apart, factoring it. You guys can talk. You know, reading lips is harder when you're wearing a mask. I see like some of you, I can tell that you're talking, but I can't even see your lips, so it doesn't work. Okay, so multiply to 2 and add to 3 would be a 2 and a 1. So what are my vertical asymptotes? And since they are lines, you have to give me the full equation. Vertical is x equals, so it'd be x equals -2 and x equals -1. It's just what makes the bottom 0. Okay, then to get my horizontal, we have to do the limit as x approaches positive and negative infinity. And we've talked about 95% of the time they're going to be the same, but we did do one problem that had a radical where they weren't. Basically, unless it has a radical or a piecewise, they should match when you do the positive and negative infinity. I can't just plug in infinity, because I get infinity minus 5 over infinity plus 3 times infinity plus 2. I can't make any sense of that. What was the trick that we used when we did limits at infinity?
Multiply by 1 over the highest power.
Yes. What is the highest power of x here? X squared. So I'm going to take top and bottom times 1 over x squared. So x times 1 over x squared will give me a 1 over x minus 5 over x squared. On the bottom, x squared times 1 over x squared is 1. 3x over x squared, 3 over x, and a 2 over x squared. Now this is beneficial because if you have a number over infinity, what does that turn into? 0. So on the top I have 0 minus 0. On the bottom I have 1 plus 0 minus 0. And 0 divided by 1 is 0. So my horizontal asymptote, y equals 0. Is this all I have to do? You really should check the negative infinity as well. Is anything going to be different? No, because a number over negative infinity also goes to 0. So you could, as long as you recognize that, if you want to put the limit as x goes to positive negative infinity, as long as I know you're verifying both, if they're just polynomials, they will match. Is that one okay? Let's do some more limits while we're on this topic. So if I asked you to find, let's see, we want to try some one-sided limits. Say the limit as x approaches 3 from the, let's go right, of x minus 2 over x squared minus 3x. So you guys should be writing these down at least, so I feel like you're listening to me. What would I have to do first here? When can I just plug it in? If the bottom isn't 0. If I can plug it in and get an answer, that's fine. Now, it doesn't matter that it's approaching from the right. No, you can still just plug it in. However, if I do that, I get 3 over 9 minus 9, so 3 over 0, so can I just plug in on this one? No. So then our strategy was to factor and see if we can get anything to cancel out first. So, x minus 2, I can't do anything with that. What can you do on the bottom? Well, add an x. Okay, if I look at this, does anything cancel? No. So let's see if we can reason through this. If I were just to plug in, the top would go to 3 minus 2, so 1, over the bottom we would have a 3 times 3 minus 3 is 0. But which way is it coming from? You're approaching 3 from the right, so you're putting in something bigger than 3. So if you take a number bigger than 3 and you subtract 3 from it, do you get a positive or a negative answer? Positive. So it's approaching 0 from the right. Okay, so the top is just a number. 3 times 0, that's going to 0. So if I take a positive number and divide it by a smaller and smaller positive number, first of all, is my answer going to be positive or negative? Positive. So if you have something and divide it by a smaller and smaller and smaller number, what does it turn into? Infinity. Anytime you have a number over 0, it's going to either go to positive infinity or negative infinity. We know it's positive because we have a positive divided by a positive. Okay. Do we need another one like that? Another one? Here, let me give you guys one to try. Let's do the limit as x approaches -2 from the left of x plus 1 over x squared minus 5x plus 6. Okay, so try that one on your own for me. Okay, because you check, you tried plugging in, but since I changed the problem on you, it doesn't work. So we have to factor. So multiply to 6 and add to 5 would be a 2 and a 3. Nothing cancels out, so we're going to try to reason through this. So the top, if you put in a -2, -2 plus 1 gives you a -1. On the bottom, -2 plus 2, that's going to 0. You are putting in something smaller than -2. So like -1.9, or sorry, -2.1, -2.5. So when you add 2, is it positive or negative? Negative. Does everybody see that? So we're approaching 0 from the negative. -2 plus 3 is a positive 1. So basically we have a -1 over 0 from the left. So if you divide two negatives, your answer is positive, and a number over 0 always goes to, so positive infinity is our answer. Is that one alright? Okay. So we asked about derivatives with e. Do we need another one like this? The left or right? Okay. So let's do something with an e in it. If I ask you to find the derivative of let's say 4e to the x over x to the 5th. What would we do here? What's the big rule we have to start with? Quotient rule. We have things being divided, so we need our quotient rule. So that's low. D high. What is the derivative of 4e to the x? 4e to the x. Coefficients stay, and the derivative of e to the power is still e to the power. Minus high. D low. Derivative of x to the 5th? 5x to the 4th. Over low, so x to the 5th, squared. Okay, let's say I really asked you to clean this up. On the bottom, what would that turn into? X to the 10th. On the top, what could I factor out? What do they... Okay, we can take out the 4e to the x. They both have that. Do they have anything else in common? Yeah, we have an x to the 4th. Okay, so on the first one, I took out the 4e to the x and I took out an x to the 4th, so there's an x remaining. Minus the second term, I took out the 4e to the x, I took out the x to the 4th, so it's just a 5. So then to simplify this, what can I cancel? I can cancel out an x to the 4th. So we get 4e to the x times x minus 5 over x to the 6th. Do we need another e to the x problem? Yes? Okay. Why don't you guys do this one? X cubed e to the 2x. Find its derivative. So we have to do this as an x cubed times an e to the 2x. So derivative of the first is 3x squared times the second plus the first x cubed, derivative of the second. So derivative of e to a power is still e to the power, but what else do you need on this one? A 2. You have to do the chain rule. Because the power wasn't just an x, you have to take it times the derivative of 2x. And so then just cleaning up, you have 3x squared e to the 2x. I'd pull your 2 out to the front. And that's really all you can do. You could factor out things if you wanted to, but you certainly don't have to. Is that okay? An implicit differentiation one? Yeah. Okay, so let's do let's see. Do you guys want to try it first, or you just want to work through it together? Try it? Okay. take a minute and do that one. Find dy dx there. On these problems. You have to watch when you need to do a product rule. How many product rules do you have to do in this problem? 2. Okay, so let's start there. If I'm looking at this first one, we have a 3x squared times the y. So I have to do the product rule for those terms. So derivative of the first would be a 6x times the second plus the first, 3x squared. Derivative of the second. Derivative of y would be plus derivative of 4x squared, 8x. Okay, the second problem that I've seen is when there is a minus in front of this. Because you're going to do your product rule, but that minus applies to all of this. You have to end up distributing it. So derivative of the first, derivative of x is just 1 times the second plus the first times the derivative of the second. Derivative of y to the fifth, what else does it need? Okay. And derivative of 8 is 0. So, first thing, that negative, you have to take it to both of those terms. We end up subtracting them both off. So I have a 6xy, 3x squared dy dx, an 8x, a negative y to the fifth, a negative 5xy to the fourth dy dx equals 0. Then you need everything with the dy dx on one side and everything without it on the other. So I'm just going to move over my 2 dy dx terms and leave everything else. So if I add over this one, subtract over that one. Is everybody with me so far? Then what do you do? Okay. I'm going to be lazy. I don't want to rewrite that. I'm going to take out this dy dx. So then what do you have to do? Divide by what's left. So we have dy dx equals 6xy plus 8x minus y to the fifth over the 5xy to the fourth minus 3x squared. Yes?
Did you accept the answer if like all the signs were switched?
Yes, if you moved it to the other side, then you would have everything at the opposite sign, and that's fine. Other questions there? Okay. I think so far we've hit everything you guys brought up. Do you have anything else? Or do you want me to just make up some things? Just give you some things? Yeah. Okay, so I'm trying to go back through and look at the study guide and things that I know I've answered questions on. So one thing, like the very first question asked you about domains. What if I gave you this and asked you to find the domain? So when we deal with domains, we have to worry about fractions and radicals, right? And this one has both. So we have to worry about two pieces. First of all, if it's a radical, what has to be true about the thing underneath the radical? Okay, so we know that this thing underneath the radical has to be greater than or equal to 0. Second thing, if you have a fraction, what can't be true about the bottom? Can't be 0. So in this problem, It's really just 4 minus 5x is greater than 0. We can't have an equal to it all. So if I solve this, if I subtract my 4, when you divide by -5, what's that do to the inequality? So that would be x is less than 4/5. How do you write that in interval notation? -infinity to 4/5. Good. No bracket because it would put a 0 on the bottom. Yes.
Actually, can we go over the velocity problems like we did on number 5?
Like we did on which one?
Number 5 of chapter 1.
Okay, so just a word problem that wasn't a velocity problem, but
Sorry, I mean like when we use the velocity equation. Like the 4/3.
you mean the volume equation?
Yeah, sorry, I don't
Okay. Okay. Yes, so let's look at something like that. So a word problem. So I told you, like, we did these composition problems. I told you the volume of a sphere I would give to you, but there are some that I would expect you to know. Like area of a circle is pi r squared. Volume of a cube, like times width times height. So those you should know. So these were, let's see, I'm trying to think back to, we did one that was like an oil spill, right? So we said, let's say the diameter, let's do the radius is increasing 2 centimeters per second. So the first thing I would ask you to do is write the radius in terms of t. So if my radius increases 2 centimeters every second, what would be our radius equation? 2t. Okay, so then I might ask you to find this one. If I did volume, that would be like a cylinder, so I don't really want that many variables. Can I just say the area of this? So if I asked you to find the area of as a function of time, in other words, A composed with R. So this is just a circular figure. So this is a formula you would have to know. What's the area of a circle? Pi r squared. So what am I asking you to do? Plug in your R. So your R was 2t squared. So if you square both of those, you get 4 pi t squared for your area formula. So I usually ask 2 things on that, just for your original radius and then for the composition at the end. Is that one okay? While we're doing more algebra type problems, you know, number 4 was a word problem. I might put something like that on there, but it was just writing the equation of a line. So you have to be able to write the 2 ordered pairs. The one thing that I know has tripped you up before, how do you know which one to put as the y value? Right. Whichever one is the function is the y. So this one on number 4, it said express cost as a function. So the cost is the function, so the cost is your y. You know, if I wanted the radius as a function of the time, then the radius is the x, or sorry, the radius is the function, so the radius would be your y. Your time would be your x. So whichever one is the function goes in the y. And then you guys can write the equation from there. We had number 3, laws of exponents. What if I gave you something like this and told you to simplify? Let's say x to the 2y times x to the y minus 4 over x to the 5y plus 3. So just testing if we know our laws of exponents. When you're multiplying, what do you do with your exponents? So if I add like terms, that gives me a 3y minus 4. Then if I'm dividing, what do I do with my exponents? Subtract them. So I have to do 3y minus 4 and subtract 5y plus 3. So if you run your negative through, we get x, 3y minus 5y is negative 2y minus 7. Okay, so you can do those rules of exponents. Can I put a few limit problems up? I'm going to put maybe 3 or 4 up, and I just want you guys to try them all. I know limits were a little bit longer ago, so we're a little more rusty with those. Let's do... Negative infinity, sorry. We don't have a ton of time. Do you guys care if I just start going through these instead of giving you guys time to work? What would you have to do on the first one? Factor. If I just plug in, you get a 0 on the bottom, so that won't work. So we factor first. So the top factors into x minus 6, x plus 1. Bottom, x plus 6, x minus 6. So the x minus 6 cancels out, and then are you able to plug in? Yeah, we got rid of the problem, so we get 7 over 12. So remember to factor and reduce. Second one, if you have an infinity problem, what do you do? Which in this case is x cubed. So if I take everything times 1 over x cubed, I get a 5 plus 2 over x minus 1 over x squared minus 1 over x cubed. over 3 plus 2 over x squared plus 4 over x cubed. The idea is anything with an x on the bottom is going to go to what? 0. So really all of those go to 0 and we're left with 5/3. Does it matter if you're going to positive or negative infinity? No, same strategy. Are those two okay? What about this type of limit problem? I can't just plug in because I'm getting 0 on the bottom. I can't just factor and reduce, nothing cancels out. What do? When we had these trig functions, we also did the same thing when we did, if we had something with radicals, like number 7c. We tried multiplying by the conjugate. So I'm going to take top and bottom times 1 minus cosine x. Okay, so that would give me limit as x approaches 0. On the top, that's 1 minus cosine squared. On the bottom, I have x times 1 minus cosine x. What's 1 minus cosine squared turn into? So we're still writing our limit. Okay. So this is beneficial because sine squared is like a sine times the sine. I'm going to put the x with one of these and the 1 minus cosine x with one of them. We had a theorem that told us is x approaches 0, sine x over x goes to what? 1. Now we can reason through this a little more. So we get a 1 times sine of 0 is 0 over, I shouldn't have made up this problem. We get 1 minus cosine of 0. Cosine of 0 is 1. So 1 minus 1 is still giving us a 0, isn't it? So are we able to reason through it yet? No. There are strategies, but I probably don't want to get too far into it right now. So this is just because I made it up off the top of my head. But had I put a little more thought into it, you wouldn't have gotten 0 on the bottom anymore, and then you would be able to answer it. Okay, so that's a bad problem, but I tried. We've got 3 minutes. What else? Do we know? Can you do limits by looking at a graph? You know, look at a graph and tell me the left hand, the right hand limits, those types of questions. Yes.
Are we gonna have like, when there's 3 graphs and you tell them like which one's y, which one's y prime, which one's y?
I probably will not put that on there.
Okay.
Next semester we're going to talk a lot more about that. So.
Can you go over like the things on the graph that make it different?
Okay, so the question is like on number 11a, you had to tell me where the graph wasn't differentiable. So that's where the derivative doesn't exist. And there are different things that can make that happen. The first one is if the limit doesn't exist. So like if the left and right hand limits don't match up. If the function itself is undefined, then the derivative doesn't exist. So talking about asymptotes. If you have a corner, because we talked about when we drew the tangent lines, you couldn't draw a tangent line at a sharp corner. There were too many possibilities. Or if you would have a vertical tangent line. I could also ask you where like a limit wouldn't exist. So we know the things that make limits not exist. Let's say I gave you something like this. Okay, I think we could all agree that the limit doesn't exist at 1. But there were 3 reasons that that might happen. A limit doesn't exist, or sorry, I want to ask where it is. I wanted to talk about discontinuity. I just did the limit. So discontinuity was the other thing we talked about. We can all agree that there's a break in the graph at 1. The reasons we had for justifying that would be the limit doesn't exist, the function doesn't exist, or those things aren't equal. Because remember, this one, clearly the limit doesn't exist. Your graph is also discontinuous if the function doesn't exist. So like this, there's a limit, but does the function exist there? No, so it's not. Or if the limit and the function aren't equal. So something like this, the function exists, the limit exists, but those things aren't equal. So it's discontinuous. So if I asked you to tell me why, those were the rules we used. You guys all know the definition of derivative. We talked about that yesterday. You'll have to do one of those. The limit as h approaches 0, f of x plus h minus f of x over h. So I will post this discussion, but if you have any questions, let me know. Otherwise, your final